After the 5 minutes, placing the test tubes A and B in the ice bath. Now we are going to slowly add the content of test tube B, which is the nitronium ion. This is the mixture of sulfuric and nitric acid. Just take 1 drop and add the 1 drop into the test tube with the methyl benzoate. Just add 1 drop at a time. Just want to show you that we're adding 1 drop and wait for about 20-30 seconds before I add the second drop. I place it in the ice all the time while I'm adding this or until I add the content. If I add too many drops or 2-3 drops at a time, you will see that a brown smoke will come out or the solution would turn brown color, which is the byproduct. I keep saying it, I know, but it's important for you to follow this and not get a brown color. Because it's taking long, I'm going to add the 1 drop every 30 seconds, mix it, place in ice, but we will pause the video for now. And when we are done adding, continue with the video. Okay, we're done with addition of the nitronium ion into the methyl benzoate. And I added like a couple drops at the same time. See what happened with this, like you got like dark color. It might work if you do like recrystallization, but it's not going to look perfect because your product is not going to be light yellow color. It might be dark color, and dark color means contamination. So I had to repeat this, and I added a second test tube. See, still there is some yellow color. Is acceptable. It's like a tan color, and it is acceptable. You just have to be very patient and add 1 drop of the time. See how much lighter than the other sample. So this is perfect. This is still acceptable. If it gets brown color, is a no. You have to repeat the experiment. So the procedure, it tells you if you see 2 layers, make sure to add an additional drops of the sulfuric acid to make it 1 layer. And often, for mixing, I don't want to use another stirring rod and agitating or swirling like this. It may not work. If you are using this like micropipette, you can pull some of the liquid up into the pipette and then dispense it back by pressing the valve for the pipette. It will mix it well, because you don't want to have the nitronium reagent on top and methyl benzoate down, adding very slowly, forming the second layer, and as soon as you mix it, it turns all brown color. So as you're adding, you can just keep mixing by pulling some of this mixture up and dispensing down. And we're going to keep based on the procedure, keep the test tube in a test tube rack until it reaches room temperature. Then we continue for another 15 minutes, keeping at the test tube rack for reaction to complete. When the reaction is complete, at that point, we will pour it over the ice. We don't have to measure about the 5 or 10 grams of the ice. To the mark of the 10 milliliter ice, enough ice for the crystallization of our product. The product, after reaching the room temperature, stayed there at the room temperature for 15 minutes for complete reaction. Now we're going to add that to pour it over the ice for crystals to form. And after the crystallization is complete, and as soon as the pieces of the ice are melted, then we need to do vacuum filtration to collect the crystals. So while I'm waiting for this process to complete or finish, we're going to use the time and measure the mass of the filter paper. Measure the mass. The mass of the watch glass plus the filtered paper, it reads 32.074. Now we are going to set up our vacuum filtration. The vacuum flask is connected to the trap, and trap is connected to the vacuum wall. We want to make sure we are using the same filter paper or pre-made filter paper. The size of the filter paper is proper based on the size of the Buchner funnel that we are using, and it should cover the openings of the Buchner funnel. You add couple drops of water, because our solvent is water, to the filter paper to make sure that when the paper stays still as I pour the mixture over. Just waiting for the ice to melt, the crystals to form before I start the vacuum filtration. Our product is ready to be vacuum filtered. To collect it over the vacuum filtration. And during the vacuum filtration, if there is any solid left in the beaker that is not, it didn't transfer, we wash and transfer with cold water. For that reason, I prepared some cold water in the ice bath here. So we wash it, we use the cold water to transfer and also wash the crystals with water. That removes anything that is water soluble, all the impurities that are water soluble out of our product. Then we are going to wash it with sodium bicarbonate. Sodium bicarbonate is going to remove any acid, leftover of the acid from the product. If the product it's tannish color like the one that we had today, we can just wash it with the methanol. If it's brown color, we must do recrystallization to remove the byproduct of dinitro or the trinitro. So the steps is going to be after the filtration, washing with cold water, washing with sodium bicarbonate to neutralize and remove the acid. Then we wash with the methanol. Because the boiling point of methanol is 65, it's nice to wash with the methanol last step, so the drying is going to be faster. So let's do the filtration. The crystals are formed in the beaker. They are nice color, so meaning that is not brown color. Turn on the vacuum first. We turn on the vacuum and we pour the mixture over. When you are trying to save the solid, you're not decanting, you're not pouring just the liquid first. So what you do, you mix it and transfer. So most of the solid needs to be transferred the first time. Anything left over, we are going to wash with some cold water and use cold water to transfer. How much you want to use cold water? You want to keep it minimum, because the more washing, more of the product can dissolve. Even the solubility in water is very low, but still you want to minimize washing with the volume of the washing and the number. But at the same time, you don't want to leave any crystals in the beaker. So as long as there is crystal, it's worth it to add water and transfer. The last part, just a few crystals left, okay? All crystals are transferred. Now, on the next step, I think I used more than the 10 milliliter to wash, but just to make sure that is for washing as well. Next step, to wash with sodium bicarbonate. For washing, the better practice for washing is to close the vacuum and pour the washing solution over the crystals for it to kind of soak, and then turn on the vacuum. You also want to make sure these solutions, if they are low temperature, for any washing solution to stay at low temperature. Since you already saw the measurement of the sodium bicarbonate and the methanol, I'm just showing you the washing steps, one right after the other one. So for washing with the methanol, also I close the vacuum. I pour the methanol over the crystals for it to kind of soak the chemicals or the crystals in methanol, give a chance to clean, and then turn on the vacuum. Okay. So I'm going to just tell you what happens if the vacuum is on and you pour the solution or washing solution, some methanol. See, as you pour while the vacuum is on, as you pour the methanol, like in this case, I'm just using methanol. See, the vacuum is pulling the liquid down right away. It doesn't allow, so one part of the crystal or the crystals in one area of the filter paper will be washed, the other area will not be washed. So to avoid that, we close the vacuum, we add the washing solution, and then, so you saw that the methanol went through right away. But if the vacuum is closed, which is in this case right now, the vacuum is closed, when I add the methanol stays, it kind of soaks everything, and then I turn on the vacuum, and now this washing is a lot more efficient. Okay, now the washing is done. We keep the vacuum on for 3 to 5 minutes for most of the solvent to be removed. Then we transfer the filter paper with the watch glass into the oven that is set at 65, 66 degrees Celsius. We want to evaporate the methanol and dry the product. One other thing is that you see the gloves change color. It's time to change gloves, especially when you are dealing with acid. If your hands or your gloves are contaminated with the acid, it will change color. It's time to change it. Just that's a better practice. Okay, it's been 5 minutes already. I'm going to turn off the vacuum and remove the Buchner funnel with the filtered paper. Now, how do you transfer to the watch glass is the same way that you would transfer cake after like baking cake. You can flip it, or you can kind of using a spatula, you can slide the spatula underneath the paper and transfer the sample with the filtered paper to the watch glass. So as long as the crystals are transferred and the filtered paper in any way, like if this spatula is not sharp enough, you can use a different cube. You can use the sharper spatula to transfer the filtered paper. We measured the mass of the filtered paper already. So if I want to find out, like if I'm concerned about the percent yield, and there are some crystals in the stock with the filtered paper, I don't want to lose that product, and I want the product in the filtered paper to count as part of the mass or the final mass of the product. So we will transfer now, as long as our watch glass and the filter paper is transferred to a clean pre-made watch glass as we had before, we can place in the oven. Okay, the oven is set at 65, so we place the sample in the oven for about 3 to 5 minutes, because the boiling point for methanol is so low, it doesn't take too long for it to dry. And after the 3 minutes, we're going to remove, measure the mass, and measure the melting point. How do we know the sample is dry? If the paper is dry, because paper with the methanol was wet. I often say if the paper is dry, the sample is dry, and also the crystals are going to be like separated from each other, is not like stuck to one another, then we know that the product is dry. What would be the problem if it's not dry? If the sample is not dry, when you measure the melting point, basically it's going to dissolve in the solvent. So the melting point is going to show less than 65 degree, because it would dissolve in methanol instead of melting. So we want to make sure the product is dry before we measure the melting point. We have our sample kind of dry. The paper looks dry. This is kind of crisp and dry. And we are going to measure the mass of the product with the filter paper and the watch glass is 32.360. And the color of the product looks good. So that gives me a hope that we get better melting point. So no dinitro. We record the mass and we are going to measure the melting point. To measure the melting point, we hold the capillary tube from close end. We tap the sample, the capillary tube into the sample to get some of the crystals into the capillary tube. So we have about 2 to 3 millimeters of the sample. We pass the capillary tube through hollow glass tube to transfer the sample to the bottom of the capillary tube. There should be no air bubbles trapped within the sample. So when it's a solid sample, about 2 to 3 millimeters, that sample size is good enough. We place in the sample holder of the melter apparatus, and we are going to turn on the machine. Based on the chart provided with the manufacturer of this melter, if the melting point is expected to be between 50 and 100, which is the case in this for this product, it is expected to melt at 78. If the product is metal product, based on the structure of the reactant, we should set the power regulator at 3 for slow heating of the sample. We don't want to heat the sample too fast, because then the thermometer needs time to catch up with the increase in temperature, or not too slow. We are waiting for the sample to melt, and I will use the picture to show you the temperature when the melting takes place. Initial melting would be when you have drop of the liquid on the sample. The top of the sample is liquefied. Final melting would be the temperature when the entire sample is melted. We have to monitor this because it's only 78, but still it's too low. It's about 25 for now.